Great. How we will proceed with the session? So I'll share one problem. I'll show problem will be visible in the screen. I'll give you some time to arrive at some solution. Those who know the solution or those who are able to solve the problem, they will write their solution in chat. Okay. And then I'll go through their solutions. And if it is right, I'll tell. If it is wrong, then also I'll guide. Okay. And after a certain time, I'll explain the exact solution of that problem. Okay. So starting with the first problem. Okay. I hope the first problem is visible to everyone. We are starting with an easy problem. Okay. Problem statement is like this. Given three sorted arrays in non-decreasing order, print all common elements in these arrays. So problem is pretty simple. There are three arrays and they have certain elements based on like number of elements can be different. Okay. Each array can have different number of elements. What you have to find is or print is all the common elements which are available in all the three. So one example is given to you. We have in first array 1, 5, 10, 20, 40 and 80. Second have 6, 7, 20, 80 and 100. And third have 3, 4, 15, 20, 30, 70, 80 and 120. So we have three arrays and in this only 20 and 80 are common which are present in both. Okay. So problem is simple. Now how you are going to solve this? Tell me in chat. I guess question is clear with everyone. You just have to find common elements and it is given only three arrays will be present. And you have to find common elements like which are present in all the three. Okay, we got one response from Tanaya. We can merge all the arrays and sort them using now after sorting using count variable we will count the frequency. If count is 3 we print the number. Okay. Okay, we got one more response from Sam Reddy Harshvardhan. Using dictionary for loop you'll go and up to the length of array sorting frequency storing the frequency in dictionary return the high frequency value in dictionary. Okay, seems correct. Okay, Nichita is saying we store elements in hash map with frequencies. Those who don't know about frequency, frequency basically means count of any element, like how many times any element is occurring in any array. So in array 1, we have 1 occurring 1 times, 5 occurring 1 times, 10 occurring 1 time. Every element is occurring 1 time. Okay. So frequency of every element is 1. Frequency basically means count. In next array, if map contains the key, we update the frequency. Else we update frequency to 0. Okay. After checking third array, we print all keys with value not 0. Okay. Nandini is saying we convert first array into list and compare the element of this list, ith remaining elements. If count of element is 2, we print them. We convert first into, okay, array into list, then compare the element in this list. Okay. Okay, common means those who are present in all the three. Common simply means those who are present in all the three. So I mentioned one term frequency. Frequency is nothing but count of elements. So if we can find count of all the elements and whichever element is occurring three times, those are the common elements. Like we have either you can create three map or hash map for finding frequency of every element in every array. And then, okay, let's see what you're saying. I'll give one more minute using three pointer approach. Okay. Then we can get this recorded video. Yes, you can get this recorded video. That is a separate part. My team will share with everyone, those who have registered and all. Registered, not registered even. You got how you got to know about this session. Some link might be shared with you. So in that particular session only, another link will be shared of the recorded video. Okay. Okay, so time is up. Okay, we got one more response from Navya. In array 1, if it is in array 2 and in array 3, print I. If it is in array 1, array... Okay, Navya, there is something wrong in your code. In Python, traverse the smallest list, and if each element of that list is present in other two lists, append into final answer and display answer, or convert them into set and use intersection. Okay, okay, okay. Now I'll explain. Three pointer respectively at each array. If all are equal, we print it. If x is less than y, I plus plus, y is less than z, y plus plus, else z is less than x, z plus plus. Okay, we can do that. Okay, first of all, whatever response I got, I'll take a single test case. 1, 2, 3, 3, 7, 9, and 10. Then we have 2, 7, 9, 9, 9, 10, 11. Then we have 3, 15, sorry, let us take 3, 7, 9, 10. Okay, I'll take 1 here. 1, 7, 9, 10, and 15 is there. Okay, suppose this is my array 1, this is my array 2, this is my array 3. So it was mentioned in the problem that my array is sorted in increasing order or non-decreasing. Both non-decreasing. Non-decreasing basically means you can have duplicates also. So non-decreasing means you can have same values occurring twice. So this array is non-decreasing. Non-decreasing, as you move from left to right, your value will either increase or will be same. Okay, so non-decreasing means can be duplicates. So those who said they will find count of, like, I think Tanaya said you'll merge the all the three arrays and then find the count of every element. If count is 3, then you'll print it. But that is wrong in this case. If I have a 3 at this point, so what will happen? T is occurring 3 times, okay, across all the elements, but 3 is not present in all the 3 arrays. I hope you understand. So first approach is wrong, okay. When you are merging all the 3 and then finding count and whoever count is 3, you're printing, that is wrong, okay. Now other approach that we got is, so you can find the smallest list or array and then try to find its element in remaining two. Okay. If its element are present in both, like in this array also, this array also, then you can print the element, and that is actually correct. But one thing is not mentioned. There is one limitation of this approach. What is the limitation? Suppose the size length of this is n, this is m, and this is o. So length of first array is O, length of second array is M, length of third array is N. So obviously to go through all the elements of this array, which contains n elements, you require n operations. Okay. Then you go through both the arrays. This array also, this array also. Okay. So this will require O plus M operations every time. Okay. So your time complexity will be n into O plus M. Okay. Anyone got confused here? So what you are doing is, so you are going through this small list, and suppose I go through this small list, first element is 1. What is my next goal? My next goal is to find 1 in array 1 and in array 2. Means in remaining 2 arrays, you will try to find that particular element. Okay. So your array 1 have O elements. So in worst case, you need to go through all the O elements. Okay. Similarly, you need to go through second array also, because you have to find the element which is in both array 1 and array 2. Okay. So this will take O plus M operations, where O is the length of array 1, M is the length of array 2. Overall time complexity will be N into O plus M. Or if I write it formally, out of these two, maximum will be considered, or if I write, it is going to be O of n into max out of O plus m. Okay. Whichever value is maximum will get here. So suppose it is given your array can have up to 10 to the power 5 elements. If this particular statement or is mentioned in constraints, if your array can have 10 to the power 5 elements, then in worst case, taking the worst case scenario, when all the arrays have same number of elements, so in that case time complexity will be n into n plus n, or n into 2n, or basically you can take n square. Okay. N is 10 to the power 5 and have 10 to the power 5 elements. N is length of array and it is 10 to the power 5. N square will be 10 to the power 10. And remember one thing, 10 to the power 8 operations are allowed. Okay, to avoid time limit exceeded. To avoid TLE, you can do 10 to the power 8 operations. But here, if your solution is O of n square, you are having 10 to the power 10 number of operations. Okay, so this can give you TLE. This approach can give you time limit exceeded error. Okay, and the third approach that we got, I think it was by Jhansi, and there was one more girl, yeah, Isha. So using three pointers. Okay, so using three pointers, we can solve the same problem using O of n operations. How we will proceed? I'll take this particular example again. Just focus how we are going to proceed with this. Okay. So there are going to be three variables, I, J, and K. I, J, and K. They will store index. Suppose I will store index for first array, J will store index for second array, and K will store index for third array. Initially, all values are going to be 0 because array always start with index 0. Let me write their indexes. This is 0, 1, 2, 3, 4, 5, 6. Okay. So first, you will find what all elements are present at index 0 in all the three. So in array 1, the value is 1. In array 2, the value is 2. In array 3, the value is 1. Okay. Now, one thing is clear. 1 is not present in all because you found a 2 here at this place and 2 is greater than 1. Your array is sorted in increasing order. It means you cannot find any more 1 after this point. Okay. So there is no more 1 left in this array, second array. So obviously 1 cannot be present in all the three arrays. So you will update your I. So your I will update it to 1 and your K will also get updated. So K is also 1. What is the element present at index 1 in array 1? It is 2. In array 3, it is 3. In array 2, we have not updated it. Okay. J is still 0. Now, element present at index 1 in array 1 is 2. In array 2, element present at index j is 2. And in array 3, element present is 3. Okay. So now again, what we can say that we cannot find 2 in all the three arrays. Why we are saying that? Because in array 3, my current element is 3 and it is given my array is sorted in non-decreasing order. So remaining elements does not contain 2 in them. Okay. Because it is non-decreasing. I cannot have a smaller value in future. Okay. So I cannot find 2. So I need to update the value of j and update the value of I also. Okay. So value of I is updated. I is 2 now. And element present at index 2 is 3 in array 1. J is updated to 1 and element present there is 7. K is updated to 7. Sorry. K is still at 3. Okay. K is at index 1, which is storing the value 3. Now, what happens out of 3, 7, and 3? So, these three are elements present at current indexes in corresponding arrays. We have 3 here, we have 7 here, and we have 3 here again. So, one thing is again confirmed. What is confirmed? 3 is not present in this array. Okay, since 3 is not present, so I cannot print 3. Since I cannot print 3, I need to update indexes in corresponding arrays. So index I is also updated. Index K is also updated. Okay. Now what happens? Element at index K currently is 7 now. Element at index I is 3 now. And element at index J is 7 now. Okay. Now one thing is clear. My current value at index I is smaller than the corresponding two values. So in this case, you have to update your I. You'll update your I. You look for the greatest value out of 3. Okay, out of 3, the greatest value is 7. So you look for 7. So you have to update the index I. Index I is updated to 4. Value present at index 4 is 7. Now at this point, 7 is present in all the three arrays. So you will print 7. 7 is printed. Okay. And next, what happens? You increment the value of indexes in all the three arrays. So index is updated to 5 in array 1, I value. J is incremented and J becomes 2. K is also incremented and K becomes 3. Okay. Now element present at index 5 in array 1 is 9. Element present at index 2 in array 2 is 9. And element present at index 3 in array 3 is 9. So 9 is common, so you can print 9. In this way, you will proceed. Okay. So whenever you have unmatching elements, in that case, suppose I have 1, 2, and 3. So one thing is clear. 1 is not present, 2 is not present in this array. So we will look for 3. We'll look for maximum value. We'll update the index in array 1 and array 2. Similarly, if we have something like this, we saw 377. So 3 is the smallest, so we have to update the index in this case. Okay, because these two arrays don't contain 3 like this. Okay, or we cannot find 3 now onwards. So that is the reason we update the value of smallest values when we have a mismatch, and we keep on moving like this. So in this way, this is a three-pointer approach. And in worst case, the number of operation you will be performing is n plus m plus o. N is the length of array 1, array 2, and array 3. Or I can say o of n number of operations. Is this clear with everyone? Anyone have any doubt, they can ask. Okay, great. There is one great observation by Preeti. Okay, so we'll consider one case. I hope this, but till now it is clear with everyone. So there is one good observation by Preeti. And the observation is, suppose I have something like this. So first you will compare I, J, and K elements at these corresponding index in corresponding arrays. Okay, here we have 9, 9, and 7. So we know that we are incrementing the index of smaller value. So K is incremented and K is currently 1. Element present at index 1 is 9 now. At J index is 9. At I index is 9. So we have equal values. So we print 9. So once we found element which is common to all the three arrays, so after that we increment the value of I, J, and K correspondingly. So I is incremented to 1, index 1. Basically, I value is 1, which is pointing at index 1. J value is 1 and K value is 2. Now, element here are also same. So, according to us, I'll print again. But this is not what problem is asking. Problem is asking us to print value only one time. Okay. So, how to tackle this issue? I don't want to print 9 again and again. So there is one very simple approach. You can store or mark used values. So once I printed 9, I will mark it. Mark it like you can use hash map for this or you can store in set. Okay. You'll change like do something, do marking like this. 9 1 means I have printed 9 and 1 is basically telling, okay, I have printed it one time. So I can print value which have not occurred till now or which I have not printed. Okay. So you need to store or mark used values or printed values in order to avoid repetition. Okay. Now I think the whole problem is clear how to tackle repetition, and first was how to print values. Anyone have any doubt they can ask before we move on to next problem. Okay, so we are moving on to next problem. Feel free to ask questions and any doubt if you have, you can ask directly. Let me open second problem. And this I think almost everyone can solve. We'll share this link also, like from where we access the problems and all. Okay. So this is the second problem. Given an array of integers which can contain both like all type of numbers, positive, negative, and zero is also present. You have to find number of subsequences such that product of maximum and minimum element is zero. So take a pen and paper and write down important points. What are the important points? You have array which can contains all the three values, positive, negative, and zero. You have to find what? Number of subsequences. What is the property of subsequence? Product of maximum and minimum element is zero. This is very important point and the whole solution lies on this point only. Okay. So you are given an array which can contain positive, zero, and negative values. Okay. What else is given? It is asking us to print number of subsequences or find number of subsequences where product of maximum and minimum value is zero. From here only you can derive one observation or some conclusion. Maximum into minimum is zero. This need to be zero. Okay. If I take one example, we have suppose minus 3, 4, 2, 0, minus 1, 3. Suppose I have this particular array. Then how many such subsequences are possible? Okay, for convenience, let us take a smaller array. Okay, so we have like six elements in our array. 0, minus 3, 4, 0, minus 1, 3. You have to tell me for this array how many such subsequences are possible. Subsequence, those who don't know, subsequence we can get by deleting some elements of array. So you can get a subsequence by deleting some elements of array without changing the order. Okay. So we can have minus 3 comma 4 as one of the subsequence. If I delete rest of the elements, if I delete 0, 0, minus 1 and 3, you'll get minus 3 and 4. I can have minus 3, 0 and 3 as one of the subsequence. This is minus 3, 0 and 3. So if I'm taking these three values in my subsequence, obviously I have to delete 0, 4, and -1. Okay. So you can get a subsequence by deleting some elements of array without changing the order. Like changing the order is very important. You cannot change the order. I cannot have 4 comma minus 3. This is not a subsequence because here I'm changing the order. Okay. Minus 3 in array is coming before 4, but in my subsequence, I'm trying to take 4 before minus 3. So that is wrong. So for this array, tell me how many subsequences are possible. Okay. And before that also, can anyone tell me if my array is of length n, how many subsequences are possible? There is one relation between n and number of subsequence. N is where length of array. Yes, there can be equal values also, Nandini, 0, 0. Great. Yes, yes. So Yamini is correct, Jhansi is correct, and Nandini is right. So if array have n elements, then 2 to the power n subsequences are possible. And one more important thing here is, out of this 2 to the power n subsequence, one is empty subsequence. Great. Okay, we got answer from Shruti also. I'll write this array in next page. 0 minus 3, 4, 0 minus 3, minus 1, 3. So we have 0 minus 3, 4, 0 minus 1, and 3. Okay, one small array I'll take to show how you can generate subsequences. So I have only one element present in subsequence. In that case, I can have three subsequences. I can have two length subsequence also, 1 comma 2. Then 1 comma 3 is also possible if I delete 2. I can get 1 comma, sorry, 2 comma 3 also if I delete 1. So these are two length subsequence. Then we have only one length subsequence also, which is 1 comma 2 comma 3. So how many subsequences are there? 3 plus 3, 6 plus 1, 7. Okay, but according to formula, we have 2 to the power n subsequences. N is 3, so 2 to the power 3 is 8. I'm getting 7. But I told you there is one empty subsequence. Okay, so now total number of subsequences is 8. How we get subsequences, those who don't have any clue? We have two options for any value. Either you can take this value or leave this. Take this value in your subsequence or leave this value in subsequence. Take this, leave this. Take this, leave this. So two options for every value. So 2 into 2 into 2, because we have n elements, it is going to be 2 to the power n subsequences. Okay. Array, I didn't got the answer for this. How many subsequences for this array are there where maximum into minimum is 0? Okay, take your time. It is a big array. Okay, one hint I would like to give you here is, or my question here is, can I take a positive and a negative number in my subsequence together? Can I take a positive and negative number in my subsequence? like which can give me this maximum into minimum equal to 0? No. Nandini is saying yes. No, it is no. You cannot take positive and negative value in your subsequence. Okay, your subsequence cannot contain both positive and negative value at same time. This is the observation. Okay. Preeti is saying 12 subsequences are possible, which give product 0. Sneha said product becomes 0 only if we have 0. That is right. So it has two subsequence. That is wrong. Sneha take 0 0 also. So there are more than two. I'll check Preeti. We have 12 or not. Okay. Sorry. Yes, a product is between maximum element of subsequence and minimum element of subsequence. Okay. Yeah, I am whatever subsequence you told is right, Sneha, but there are not just two subsequences, there are more than two. Version 14, Varshini is saying 14, okay. 32, okay. 12, Nandini is saying 12. Sir, can subsequences be repeated? Repeated in the sense they can have same elements, but elements need to be present at some different index. You cannot take subsequence which contains same index elements again and again. Like you cannot take, you can take 0 comma minus 1 as one subsequence and 0 comma minus 1 as one subsequence. These two are different because they both are present at different index. Okay. 10. We are getting mixed answers. 15. Okay, Tana is saying 15. I'll give 2 more minutes. 12, 12. Okay, let's see. Like majority of you said 12. We got 14 also. We got 32 also. We got 15 also. Let's see who is right. 11. Jhansi is saying 11. Okay. Okay. 21. Oh man. Okay. Okay, okay. Now I'm explaining. Let's see how many are there. First of all, there are only three variety of subsequences possible. My maximum and minimum value, I'll tell. Okay, one subsequence, one type one subsequence is when maximum value is positive, minimum value is zero. Type two is when maximum value is zero, minimum value is also zero. Type 3 is maximum value is zero, minimum value is negative. I hope everyone agree with this. You cannot have both positive and negative values in your subsequence who will satisfy this condition. It is very simple. If you have something like this, 4 0 minus 1. This is a subsequence. 4 0 minus 1 is a subsequence. Here maximum value is 4, minimum value is minus 1. At any point of time, maximum value when it is positive and minimum value is negative, their product will never be zero. To have a product zero, you need either one of maximum or minimum or both to be zero. So that is what I have written here. We have three cases: type 1, type 2, and type 3. And your task is to find how many type 1 subsequences are there, how many type 2 subsequences are there, how many type 3 subsequences are there. Okay, now I'll show for one of them how to find for type 1. For type 1, total you need to count how many positive values are there. How many positive values do I have? I have 4 and 3. They are positive. 0 is not positive. 0 is non-negative. Always remember there is a difference between positive and non-negative. Non-negative means 0. Positive means value greater than 0. So there are two positive values, 4 and 3. Okay. So two positive values are there. If I want to form subsequence between them, so how many subsequences are possible? Subsequences that are possible is 2 to the power 2. Out of that, one is empty. I don't want an empty subsequence because type 1 means there should be at least one positive value in your subsequence. Okay. So total number of subsequence you can have which are non-empty, which contains positive numbers is this much. Okay. How many zeros are there with me? Zeros available with you are 2. Zeros is 2. Okay. And in your subsequence, you want at least one zero with you. You want at least one zero. Here, zero is occurring two times. How many subsequences you can have for that? You can have 2 to the power 2 subsequence. And you need at least one zero. So you need to avoid empty subsequence. So these many non-empty subsequences you can have which contains only zero. These many non-empty subsequence you can have which contains only positive values. Now, total number of subsequences which contain at least a positive value, at least a zero is equal to multiplication of these two. So this comes out to be 3 and this comes out to be 3. So this is 9. Okay, 9 such subsequences you can form. Okay, according to the formula. Now, for this case, for type 2 you can tell directly. For type 2, maximum, minimum, like you need what? You need only subsequence which contains 0. How many such subsequences are possible? This many. So, plus 3. So, that comes out to be 12. Now, for this case, again, you know this. For 0, how many non-empty subsequences you can create? That is 3. How many negative non-empty subsequences you can create? Means which contains negative value. So we have only two negative values, minus 3 and minus 1. So two negative values are there. Number of subsequences can be 2 to the power 2. Non-empty is 2 to the power 2 minus 1, which is 3. This is 3 and this is 3. So here also you are able to create this much. So total number of subsequences is coming out to be 21, and 21 is the answer in this case. Now I think someone said 21. Who was that? Navya Bharti. She is right. It is 21. Okay. Navya is correct. Rest everyone is wrong. Anyone have any doubt, any part which you are unable to understand? Tell me. Okay. I'll go slow. I'll take a simple example. For this array, how many subsequences are possible whose maximum and minimum element product is 0 for this array, which contains three zeros? Everyone tell me how many subsequences are possible where maximum into minimum is equal to 0? No, it is not 8, 7, 7. Because if we go by the formula, n is 3. So 2 to the power 3 subsequences are there, but one is empty. So we need at least one element in it. So these are non-empty subsequences. So I can write also 0, 0, 0. Better if I write their indexes. These are indexes. I'm writing indexes. So subsequence will be formed by element at these indexes. Okay, I'm forming the subsequence by writing their indexes. 0, 2 and 1, 2 and 0, 1, 2. So these are the 7 subsequences that you can form where maximum element and minimum element product is 0. So for type 2, it is clear. For type 2, total number of subsequences that you can form where maximum is 0 and minimum is 0 is nothing but 2 to the power number of zeros minus 1. Is this part clear with everyone? We have three types of subsequences. We can form three type of subsequences. For type 2, this is the formula. You just ignore all the positive negative values. Rest you will have only zeros, and with the help of zeros, how many subsequences you can form. So subsequences that you can form is 2 to the power n, where n is the number of zeros. Non-empty is going to be 2 to the power n minus 1. Okay, n is nothing but I will write nz, number of zeros. So it is 2 to the power nz minus 1. Okay, then I understood till here. Yeah, anyone have any doubt they can ask. Now coming to part 1 or type 1. So we have like this. I'll take this array only. 0, 4, 0, 3. 0, 4, 0, 3. For this, how many? Tell me the subsequences which contains a positive value as a maximum and as a minimum we have 0. This is type 1. Type 1 of subsequence where the maximum value is positive and minimum value is 0. How many such subsequences are there? It is not 6. It is 9, Tanaya. Let me write them. So I'm writing index in green color. 0, 1, 2, 3. So one subsequence can be formed like this. Other subsequence can be formed like this. Other subsequence can be formed like this. One more subsequence can be formed like this. Okay, wait, we are missing something. We have 0, 1. We take these two. 0, 1, 3. We have taken 0, 1, 3. Yeah, we have 0, 3. We have taken. We can take 2, 3. And we need one more. We are missing one more subsequence. No, no, which contains a positive value. 0, 1, 2, 3 is done. Yes, great. 1, 2. Okay. Yes, great. Preeti and whoever said that, Tanaya. Yeah. So, Tanaya, we have 9 subsequences. Okay. But how we are getting those 9 subsequences? Very simple. We are collectively taking positive values. So, for 4, 3, how many non-empty subsequences we can have? Non-empty, why? I am just saying, okay, for positive value, let us find non-empty positive subsequence. And for 0, let us find non-empty 0 subsequence. So if we can find how many non-empty positive subsequences are there, and we can find non-empty 0 subsequences are there, then their product will tell you total number of type 1 subsequence you can form. So we have two elements, 4 and 3, and total number of non-empty subsequence in this case is 2 to the power 2 minus 1. 2 is length of a number of positive values, which is 3. And we already saw 0, how many we have two zeros. So non-empty 0 subsequence we can have is 2 to the power 2 minus 1, which is 3. So total number of type 1 subsequence is 3 into 3, which is 9. Okay, you are trying to form type 1 subsequence. In type 1, you need at least one positive value and at least one zero value. Okay, zero will act as minimum for you and positive value will act as maximum for you. Okay, so total number of subsequences are product of them non-empty, like individually. Okay, I hope this is clear. Similarly, we will find for negative values also. Okay. So if I, so these are the three types, type 1, type 2 and type 3. In type 1, maximum value is positive, minimum value is 0. In type 2, maximum value is 0, minimum value is 0. In type 3, maximum value is 0 and minimum value is negative. So find all type of subsequences and addition of them will tell you total number of subsequence. Now I think it is clear with everyone why we have 21 subsequences in this case, okay, which satisfy the condition. Is it clear with everyone? Those who understand, write yes in chat. Okay, great. Anaya, Preeti, Nandini, Bhumika. And those who have doubt, they can freely ask. Okay. Okay, Yamini also understood. Okay. Okay, so anyone have any doubt, they can ask. I'm giving you time before we move on to next problem. Why are we doing 2 to the power n minus 1 two times in max and min case? Simple, wait. Okay, one final take 0. I'll take the previous example 403. For this, the answer was 9. What I am saying is, let us collectively take positive numbers and form all their subsequences. So one subsequence is this, one is this, one is 4 comma 3, and there is no more subsequence. Now so this will act as maximum for me. If I want to form type 1, type 1 means your maximum is a positive value and your minimum is 0. Okay. So for minimum, we will take all the zeros and try to form non-empty subsequence. We have 0, 0, 0, 0. Okay, these two are different. This 0 is at index 0. This 0 is at index 2. Okay, so these two are different. One is present at index 0. Other one is present at index 2. Okay, so now simple question, how many combinations I can form? Like how many total? If I want at least one non-empty subsequence which contains, sorry, at least one positive value and at least one zero value. So how many combinations? For this, I have one option here, one option here, one option here. Three options for this. So subsequence that I'll form is 4 comma 0. Sorry, in this case, 0 will come first because 0 is coming first in array also. Next subsequence is 4 comma 0, and after that we have 0 comma 4 comma 0. This is one, like three subsequences that you are able to form where 4 is the maximum. Okay, now in next stage for this you have again three options, and the subsequence will form is 0 comma 3, 0 comma 3, and 0 comma 0 comma 3. Okay, now for this again three options. So that's why we are multiplying. These are non-empty positive subsequences. These are non-empty zero subsequences. And if I want to find total subsequences where I have at least one positive value, at least one zero value, it is nothing but product of them. Okay. So 2 to the power positive numbers minus 1 into 2 to the power 0 minus 1. So that many subsequences of type 1 you can have. Is it clear, Varshini? Okay. Anyone have any other doubt they can ask before we move on to next problem? Okay. So I assume no one have any more questions. So we are moving on to third problem. So third problem is like this. You are given two arrays. This is very good problem. I really liked it. There are two arrays A and B, and you can perform only one operation either on either arrays, like either on A or on B. In one operation, what you are doing, either you can decrease array element by one or increase by one. So it's on you which array you are choosing, which element you are choosing. You can either increase the value by one or decrease the value by one. You have to find minimum number of operation to make smallest element of A greater than equal to largest element of B. So this is what you have to do. Think about the solution. Okay, Tanaya is saying here minimum number of operations can be three. We can increment value one of array A by three one at time. Okay, which will be equal to 4. No, what you are saying, Tanaya, is by incrementing one three times, we get answer and count will be 3. But in that case, 2 will be minimum of your array, not If you increment first element to 4, rest element will be 2 comma 2 comma 3. Now what is the minimum in this array? Minimum is 2. Okay, and 2 is not greater or equal to maximum here. Okay. Okay, remember you are modifying array. So minimum is also getting modified. So if in this case, if I increment my first element two times, it will become 3, and rest of the elements will be 2 comma 2 comma 3, like no change. Now this is my array, and here what is the minimum value? It is 2. Okay. So as you are modifying elements, your minimum is also changing. Okay, I'll write the constraints in whiteboard. Wait. So problem is like this. You have two integer arrays, A and B. Okay, both have same length. And constraint you can assume like this. Okay, elements are between 1 to 10 to the power 5. Your goal is to make minimum of array 1 either greater or equal to maximum of array 2. For this, you want to find minimum number of operations. But in step 4, at a time, they decrease the value of 3 to 2 and increase the value of 1 to 2. Wait. Mhm. Okay, the array which was given to you, what was the array in this case? 1, 2, 2, 3, and 1, 2, 3, 4. 1, 2, 2, 3. This is your array. 1, 2, 3, 4. This is your array B. Now you have to find the minimum number of operations. such that minimum in array 1 is greater or equal to maximum in array 2. So you can increment this. So this will become 2, 2, 2, 3. You can decrement this 1, 2, 3, 3 we have. Okay. I think the second array was 1, 2, 3, and 4. Okay. Okay, wait. Wait. How we are getting 4 in this case? Okay. Yeah. Okay, we will get 1, 2, 3, 3, 1, 2, 2, 3, 1, 2, 2, 2. Yeah, so yes, correct. Yeah, it is right. Simple. You will decrement these two values to 2. So it will take one operation. It will take two operations. So number of operation is 3. And then you will increment this value to 2. So you'll have 2, 2, 2, 3, and 1, 2, 2, 2. So three operations in array B and one operation in array A. So number of operations are 4. Yes. Second array largest is 2. Yes, Preeti. Yes, Nandini. Ashwarya, you understood like what we are doing? We are making this 1, 2, 2, 2 of array B and converting array A to 2, 2, 2, and 3. So here one operation is required and here three operations. So number of operations is 4. No, we are not performing one operation on two arrays at a time. So in operation 1, we reduce this 4 to 3. So in operation 1, after operation 1, your array look like this. In operation 2, what we are doing, we are decrementing suppose this value to 2. So your array look like this. In operation 3, we are decrementing this value to 2. So your B array is converted to this in 3 operations. And now on operation 4, you are converting first element of array A to 2. So your array look like 2, 2, 2, and 3. So the minimum element is greater or equal to maximum element of second array. So four operations you are performing. You cannot perform two operations like at same time. Okay. In one operation, you have to choose either A or B. Okay, one more minute I'll give. After that, I'll explain. Okay, so there was some typing mistake, I guess. Yes. Okay, a humble request, rename yourself and add your college and year also. Like if you are from MVSR and from 25 batch, just add MVSR 25 at the end. There is one rename option. Okay. Mhm. Okay, few now I'm explaining few tips I would like to give here is in this problem. Okay, was it given array sorted? No. Okay. Okay, in this particular problem, if I sort an array, is it going to affect my answer? Suppose I have elements like this 4, 1, 2, 3. If this is my array, in this case also minimum number of operations going to be 4 only. In case of this array also, if my B is like this, then also number of operations is going to be 4 only. If I have 2, 1, 3, 4, in this case also number of operations is going to be 4 only. So order of element is not actually like having any, what I can say, effect on my answer. So order of elements are not important. Okay. Order is not changing my answer. So when order of elements is not important, remember one thing, always sort the array. Always. In every type of problems, if order of elements is not important, sort the array. Okay. If order of elements is not important. Reason is very simple. On sorted array, you can perform lot of operations very efficiently. Okay. There are multiple algorithms also which work very fast in sorted arrays. Okay. So whenever order is not important, always sort the array. In this case, order of elements was not important. So first task you'll do is you will sort your array. Although in example it was given like in sorted form only. Okay, just to confuse you. But whenever the order is not important, you will sort the array. One thing those who noticed is n is up to 10 to the power 5. Now tell me what is the worst time complexity that is allowed in this case? Worst time complexity. Remember, I told you 10 to the power 8 operation. Take that as boundary. Okay, what is n square going to be? It will take 10 to the power 10 operations. Better than that, we have n into square root of n, which will be like 10 to the power 5 into 300 something, like 320 or 30 something. So it is again going to be 3 into 10 to the power 7 or 4 we can take roughly. Still, it will not give you TLE. N log of n will take log of 10 to the power 5 is 18 something into 10 to the power 5, or you can take 20 also. So it is going to be 2 into 10 to the power 6. So this is the worst case time complexity, which will not give you TLE. N square will give you TLE. So this will help you like, okay, restrict your thinking process also. Okay, you cannot have something which is worse than n square root of n. Okay. And usually in whenever your array is close to 10 to the power 5, either the solution accepted in most of the cases is n square root of n or n log n. In 80 to 85% of cases, the expected solution is n log n. In rest of the cases, it is n square root of n or O of n. Okay. Just keep that in mind. Okay. So this will help you save your time. Okay. Okay. Now moving forward to the answer. We have this constraint also given. Your array does not contain very big elements. It contains only element from 1 to 10 to the power 5. Okay, let us go like this. If what can be the brute force way? Brute force way can be you will run a loop from 1, not even 1. In this case, you will run a loop from 1 to 3. You will try to, okay, not 3, it is going to be 4. You are going to run a loop from 1 to 4, and you will try to make, so you are trying to fix minimum element. Okay, minimum element of array A. So minimum element of array A can be from 1 to maximum element of entire like both the arrays. Okay, reason being you don't want to convert your array A to 5, because if here the maximum element of array B is 4, what is the point of doing one extra work? For value 4, your array will satisfy the condition, so there is no point checking for value 5. Okay, so you will check for value 4 only, till value 4 only. Okay, here you are trying to fix minimum value of array A. What can be my minimum value? So your minimum value can be anywhere between 1 to 4. What is 1? 1 is the minimum value of array A. So if I write like this, for minimum element of array A, you have option between minimum element of A till maximum element of B. Okay, you have this particular option only. You can have minimum element of A between this only. If it is greater than or equal to maximum element of B, your condition will be satisfied. What is the condition? Minimum element of A should be greater than equal to maximum element of B. So that will be satisfied. Now for every value, what you will try to check is how many operations you have to perform on array A and how many operations you have to perform on array B. Because you want to make sure all minimum element should be equal to anywhere between the chosen number. Okay. Suppose you choose some random value x between 1 and 4, and you want your minimum element of array to be x. So you need to make sure all the elements of the array A are greater than equal to x, then only your minimum element will be x. Okay. And what operation you have to do on B? You want to make sure the maximum element of array B are less than equal to x. These operations you have to do. Okay. Sum of that will give you total number of operations. So I'm writing OP1 like operation number of operations you are performing on array 1, and OP2 number of operations you are performing in array 2. Now here if you try to do it brute force using brute force approach, in worst case this can be up to 10 to the power 5, from 1 to 10 to the power 5. So you are performing 10 to the power 5 operations. And for finding this operation 1 on array, you have to go through all the elements of array A. So that will take again n times, like n operations. So n in worst case can be 10 to the power 5. So this is O of n square approach. Like in O of n square, you can find it easily what should be the minimum element of array A, or sorry, minimum number of operations such that minimum element of array A is greater or equal to maximum element of array B. So these many operations you are taking, but as we already have seen earlier, O of n square will give you TLE. So we need to optimize this approach. So you have to think like this, how you can optimize. Is there a better way to find operation 1 and operation 2? Because you have to check for all these values. That is fixed. You cannot skip any value in between. So that one thing is fixed. Now, can you optimize this part? How you are finding minimum number of operations for array A and minimum number of operations for array B, which is required to make sure minimum element in A is X and maximum element in B is X.
Hello.
Yes. Okay. Any doubt, anyone? Like, avoid disturbing the session. My array A was 1, 2, 2, 3. My array B was 1, 2, 3, 4. So for minimum element of A, what options I have? I have option from 1 to 4. Okay. If I want my minimum element of array A to be 1, then how many operations I have to perform in array A to make sure my minimum element is 1? You have to perform 0 operations because all the elements are greater than equal to 1. Okay. So OP1 is 0. Now, how many operations I have to perform in array B to make sure the maximum element is less than equal to 1? So do I need to change this? No. Do I need to change this? Yes. You need to make it to 1. So how many operation you are performing? One operation. Here you need to change this to 1 again. So how many operation you are performing? 2. Here again it is going to be 3 operations. So total number of operations is 6 for making sure B have maximum element less than equal to 1. So for this case, you are having 6 number of operations. Okay. For value 2, like if you want to make sure minimum element of array A should be 2, in that case, how many operation you have to perform on array 1? OP1 is for that. Okay, do I need to change this value? Yes, this value is 1 and you need to change it to minimum value which you want, which is 2. So I want to convert to 2, I have to perform one operation. Do I need to perform any operation here? No. It is 0. Here 0. Here 0. Okay. How many operation I have to perform in array B? I have 1, 2, 3, and 4. Do I need to perform any operation here? No. It is already less than equal to 2. No operation. Here 0. Here one operation. Here how many? Two operations. Okay. So total operation is 3. So for this minimum value of A, you have to perform 3 operations. Sorry, 4 operations. 3 operations in this part, array B, and 1 operation in array A. So it is 4. Okay. Now same thing for value 3. For this value. If I want minimum element of array A to be 3, in that case, how many operation I have to perform on each element? For this, I have to perform 2 operations to make it 3. For this, 1 operation. For this, 1 operation. For this, 0. Okay. Number of operations here is 4. 4 operation on array A. In array B, how many operations I need to perform? Do I need to perform any operation here? No. It is 1. So total number of operation is 1 plus 4, which is 5. If I want my minimum element to be 3, and so on, you will check for every other value between 1, which is nothing but minimum of A, till 4, which is nothing but maximum of B. Okay. But you want to make this process optimal. Since you have to check all the elements, like all the numbers between 1 and this maximum value, there is no escaping. You have to perform this. Okay, you have to check for every value. Now, can you make this task, finding of operation 1 and operation 2, more optimal? Can you optimize this process? Because I cannot optimize anything here at this point. Because as you can see, for 6 it was 1, for 1 it was 6, for 2 it was 4, for 3 it is 5. So it is not following any pattern. If this would have followed any pattern, I would have directly implemented binary search there. Because whenever some pattern is being formed, you can implement binary search there. Like whenever you can predict what will happen if I decrease the value, what will happen if I increase the value. If you can predict that thing, or if you know that thing, you can use binary search there. But here I can see for 1 it is 6, for 2 it is 4, for 3 it is 5. So it is going like this. Okay, it is not following any pattern as of now. So what should you do is you have to try all the options. So here you cannot optimize, but can you optimize in finding number of operations for array A and number of operations for array B? Can you optimize this? Think about this and there is the answer. The answer for this is yes. Give it a try. How you are going to optimize this? What you are doing in operation 1? In array 1 you want, suppose your minimum element is currently x, you want minimum element to be x in array A. So there is no need of changing value which are greater than equal to x in array A. There is no point. You only have to change value or update those values which are less than x. Okay. You want to make all of them equal to x. Just one simple thing here. 1, 2, 2, 3 here. Obviously, if you can find, okay, I at the start I told you if Order is not important, sort it. So you can sort it. Now you can find last element which is smaller than x. So this is the element which is smaller than x. Suppose x is 3. Suppose x is 3. For this case only I am telling. This is my array A which I have sorted. Okay. What I want from array A, I want all the elements to be greater than equal to 3. So all the elements which are less than equal to 3, sorry, less than 3, I have to update them. I have to perform operations on them. Which all values are smaller than 3? So 1 is smaller, 2 is smaller, 3 is smaller. Now since my array is sorted, I can find index of the last element which is smaller, 0, 1, 2. So index of this element is 2. Okay. I can find this index using binary search. I hope it is similar to finding the biggest value which is smaller than next. Biggest value, sorry, instead of biggest value, we are looking for biggest index with value smaller than x. This is what we are looking for. I want the last index of value which is smaller than x. So here the index is 2. So I need to change all values from 0 to 2. I need to change all values from 0 to 2. I want to convert them to 2 to 2. Okay. But I have one, I want to convert them to 3. Sorry, my bad. I want to convert them to 3, 3, 3. I want to convert all values from index 0 to 2 to 3, 3, 3. Then only my minimum element of array A will be 3. Okay. And I want that only. So I need to change these values. So how I can quickly find how many operations I have to do now? There is one special kind of arrays known as prefix arrays. We are going to use those. Okay. If you know what is the sum of these values, what is the sum of these values? If I have a prefix sum array, it will store 1, 3 and 5. So prefix array store some details. Prefix of I store some details from index 0 to I, some special details. So here we are storing some. Why we are storing some? It will help us find number of operations which are required. Okay. How they will help? We'll see. Here, this is the last index which is smaller than 3. Prefix sum till here is 5. Means sum of all values from index 0 to this point is 5. Okay. If I want 3 till this point, from start to this point, I want 3. So what will be sum of these values? Sum of these values will be nothing but number of elements into 3. Number of elements is 3 into 3, it is coming out to be 9. Okay. So here if I want 333, their sum will be 9. What is the sum at this point? Prefix sum, sum of all values from 0 to index 2 here, it is 5. So how many operations I have to perform? It is 9 minus 5, 4. So you have to perform 4 operations. So with the help of prefix arrays, you can quickly find how many operations you have to perform. So here in this problem, we are going to use binary search for finding indexes, important indexes, and we are going to use prefix sum arrays. Prefix sum arrays are special kind of arrays which store some information. So prefix of I will store information from index 0 to I. If I'm creating a prefix sum array, it will store sum of elements from 0 to I. Now Suppose I was trying to make my array, sorry, minimum element of array A equal to 3. And my array was like this, 1, 2, 2, 3. So what I did, I find prefix sum array. Let me write their indexes also, 0, 1, 2, 3. So I found the prefix sum array and it is 1, 3, 5, 8. So what this prefix of 2 is equal to 5 means, it means sum of all values from index 0 to this point is 5. And I can see 1 plus 2 is 5 only. Okay. Now I can, using binary search, I can find the last index which is smaller than x in array A. This I can do using binary search because my array is sorted. And binary search will take log of n time. Okay. Now, using prefix arrays, we need to create prefix arrays before implementing this. So when we have a prefix arrays, I can directly see, okay, what is the sum of values till index 2? Sum of values is 5. But what I want to change all those smaller values to 3. This is the modification I am doing. So now, if I do that, then my sum will be equal to, since all values are getting converted to 3, so number is fixed, value is fixed. How many elements are there? That will give me sum, number of elements, 3 into number of elements. So this is the value and these many elements are there. Like I want to convert these many elements to 3. So that will give you sum of all these values till this index 2. So because I want to change all values from index 0 to 2. So this will be 3 into 3, it is 9. So when modification will be done, in after modification, the sum will be 9, but currently it is 5. So I need to perform additional 4 operations. So with the help of prefix array, I can quickly find this. Finding this value, you can find directly value into number of elements. Okay. And finding any element at any index I on array takes O of one operation. So in log of n times, like you have reduced the time complexity which was earlier O of n when you have to go through all the elements of array A. Now you can do the same operation in log of n time. Okay, with the help of binary search and prefix sum. Before moving forward, we will do the similar thing for B also and we can find that. But before moving to that part, is it clear till now? Those who understood, right? Yes, please. Okay, Nandini understood. Tanaya understood. Avisa understood. Jhansi also. Sneha also. Anyone have any doubt? They can ask. Okay, these are like very important concepts. Okay, moving on. So this is what I want my minimum value to be. I have option from 1 to 3 and 4. Array A is 1, 2, 2, 3. Array B is 1, 2, 3, 4. Okay. So for array A, I can do the same thing. Now for array B, what I am doing in case of array B? So in case of array B, what I want, maximum element to be less than equal to X. So which elements I need to change? Suppose I want my X is 3. X3 means minimum element of array A I want to be 3. Now, which all element I need to update in array B, sorry, in B array. So you have to update those elements which are having value greater than X, which are having value greater than X. So can I do the same thing here using brute force? In brute force, I have to go through all the elements. If I make some changes like 1, 2, we have 4 and 5 is there. I'll make some changes. 1, 2, 4, and 5 is there. If x is 3, if x is 3, so I need to change all values beyond this point. Remember, we have sorted the array. Why we have sorted? We checked because order is not important. So we sorted it. Because in future, we might do some operations and it is optimal to perform operations in sorted array. So you have to change these values. What is the property of these values? These values are greater than x. Now, you'll change these values to 3 and 3. Okay. How can I use prefix array here and binary search? Tell me this. For array A, we have to change elements which are smaller. For array B, we have to change elements which are greater. So it is reverse of what we did in array A. So we can use the same concepts here also. Slight changes are there. We have to use prefix array and binary search here. How we are going to use that? I want from your end. Tell me. I have to change these values. What is the sum of these values? 9. Okay. How many values I'm changing? Can I find this? Yes, I can find this if I find index of this. And with the help of binary search, you can obviously find the index of first element which is greater than x. Since array is sorted, if you find the first element which is greater than x, rest all the elements to its right will be greater than x only. So you have to find index of first element greater than x. Okay. And we can do this using binary search since array is sorted. Okay. So using binary search, you can find the index of first element which is greater. Now, once you know the index, so you have to change all values from 2 to the very end. Index 2 to the very end. So you can find number of elements. Yes, number of elements is going to be n minus this index. N is 4, 4 minus 2 is 2. Okay. N minus index. I. I is nothing but index of first element which is greater than x. Okay. You can find number of elements. And you want to change all those elements to 3. Okay. So their sum will be 2 into 3, which is 6. Okay. What is their current sum? Their current sum is 9. So how many operations you have to perform? You have to perform 9 minus 6, 3 operations. So we are doing almost similar task here. But point here is I can find this with the help of binary search. You can find the index. But how to find this sum? You can calculate this sum also. What is the sum going to be after changing those values? How many values you are changing? You can get from this formula n minus I, where I is the index of first element which is greater than x in B. So with the help of prefix array, how you are going to find some of these values? Some of values from index I onwards to the end. Prefix array at last index minus prefix till the element greater than x. Close, pretty close. So 1, 2, 4, 5. This was my array. If I write the prefix array will be 1, 3, 7, and 12. So you have to find 12 minus 12 minus, you have to remove this part. Means you don't want some of this part. You know the index I, which is at for this value. So it is going to be 12 minus prefix of I minus 1. Does this make sense? You don't want sum of values from 0 to I minus 1. So you are removing this from prefix sum of whole array. So this will give you some of this remaining part from index I to n minus 1. It is similar like if you know sum of this part and you are looking for sum of this part, so then just simply remove sum of left part, this. So that is what you are doing. 12 is nothing but you can say total sum also, because prefix of n minus 1 is going to be total sum only, sum of all the elements. So total sum minus prefix of I minus 1 will give you sum of element from current index to the very end, like from index I to the very end. So you can get the sum in that case. But be aware of the case when I is 0. When index is 0, in that case, you cannot find prefix of I minus 1. Okay? Because I minus 1 in that case will be 0 minus 1, which is minus 1. And minus 1 is not a valid index. Okay? So if your I is 0, in that case, you have to consider all values from 0 to n minus 1, which is total sum only. Okay? So now what I can conclude is 1, 2, 4, 5 is there. Their indexes are 0, 1, 2, 3. With the help of binary search, you can find, suppose x is 3. You have to find first index with value greater than 3. So this is the first index. Now, once you know the index, you can find how many elements are there whose value you need to change. That you can get by n minus I. N is length of number of elements in your array, 4. What is I? 2. It is 2. So you are going to change or you need to change two values, okay? And how you are going to find sum of those values? Sum of changed values is simple. 2 into 3. Number of elements and what is the value going to be? It is 6. So after changing those values, their sum will be 6. But what is their current sum? So with the help of prefix sum, we can find that 1, 3, 7 and 12. So we have to find prefix of I minus 1. But before finding this, check if I is not 0. Okay, if I is 0, in that case you need sum of all values from 0 to end, which is nothing but total value. So total minus this value will give you sum of remaining elements, like sum of 4 and 5. Total is nothing but sum of all values. Sum of all values is 12. Prefix of I minus 1, I is 2. Prefix of 1 is 3. 12 minus 3 is 9. This is your current sum. this is what you want. Like after changing your sum will be 6. So how many operations you are performing? 3 operations. So you can find this using prefix arrays and binary search. So now your time complexity is reduced again from n to log of n. Actually, you are performing log of n plus one operation for finding this value. Okay. So it is log of n only. Now, I hope like it is clear with the help of binary search and prefix sum, we can solve this particular this problem in maximum value of b into log of n times. Okay, anyone have any doubt in this? Okay, shall I move ahead? I got time from 7 to 9, but I have few more problems. Do you want me to cover those problems or do you want me to end this meeting here? Everyone, write in chat there. Those who want me to continue, write one. Those who want me to stop here, write two. Can you show the first two problems I missed? I guess you'll get the recording and also the problems. Okay, so we'll wind this session here only. Tomorrow also we'll conduct one more session. We will have one more session. Okay, anyone have any doubt in this? They can ask. What I can say, a recap or summary how we are going to solve this problem is first, what was the problem? Problem was you have to find minimum operation to make minimum element of A greater than equal to maximum element of B. So you are given two arrays. First thing that you have to do is you have to sort both the arrays. Why you have to sort both the arrays? Because order of elements was not important. Okay. What is the second task? Second task is you will check for every value from minimum of A till maximum of B. Current maximum of it, right? Current minimum of A till current minimum of B. You will check for every value in between because these are your options. Okay. Now for each of these values, suppose x is the value currently. What is x? X is minimum of A. You want your minimum element of A to be equal to x. So you are running a loop from this point to this point. At any point x, you want minimum element of A to be x. So you have to perform operation on array A and you have to perform some operations on array B also. What operation you have to perform? You have to change all values which are less than x in array A to be equal to x. And what operations you have to perform in B? You have to change all values which are greater than x to equal to x. Now there is a brute force way you can go through all the elements, but that will take n operations, like whatever number of elements are present. Okay. But here we need to optimize this. We can optimize this. So how you can optimize? First, since your array was sorted. So before going to second step, let me write it third. Second step is you'll create prefix array. You'll create prefix sum array for A and prefix sum array for B. What those prefix sum array will store? So prefix of I will store sum of all values from index 0 to index I. Okay. So they will store this. Now after doing this, you will perform the third operation. This going through all the elements, and for current value x, you will try to make it to be minimum of A and change maximum like values greater than x to be equal to x in B. Okay. Now for this operation, you have to find last index of element which is less than x. Once you find that, suppose that index is I, so you need to change all values from index 0 to I equal to x. You need to change to this value. So how many operations you will perform? You will perform prefix of, sum of, first you will find what will happen if all values from 0 to I is x. So you'll find that sum first. So that will be nothing but x into I plus 1. Number of values into x. Minus what is the prefix sum? Prefix of I. So what we did in this case. Okay. So what we performed here is what is the prefix sum and what will be the sum once we will update the value. So based on that, you'll find how many operations you are performing. Where I have written yes, prefix of this minus that particular sum. In this case, it is a bit reverse. You'll find index of first element which is greater than x. Index of first element which is greater than x. Once you find that, you just have to find the effect, like how many operations you have to perform. And that is nothing but this part. You have to find some of these values from index I to la end. And how you can find? You can find by doing this operation. Total sum minus prefix of I minus 1 means sum of these values. If you remove from total sum, you will get sum of this. So this is your current sum. What will be your sum after operation? This is that sum. And number of operations is difference between them. Okay. So you can find that. So this all operations you have to perform for this problem. Okay. That's all for this session. We will take one more session tomorrow. I have few more problems to cover. Okay. In the meanwhile, if anyone have any doubt, they can ask. Rest can leave. Okay. Session video will be shared with you. I'll ask my team to share the session video. Okay. Most welcome, Tana. Anyone have any doubt? I'm going to wind this session. They can ask before that.